Hey, welcome everybody. It is my pleasure today to introduce today's Hanover seminar speaker, Claudia Bartlick. Claudia, I'm Mike Walters. A lot of people don't know me. I'm a somewhat recently retired professor of silviculture. Claudia's been working with me since September of 2024, I believe. So Claudia got a master's degree at Kiel University in Germany, focusing on plant physiology as much as anything else. She went from there to pursuing a doctorate at Michigan Tech University in 2019, 2020, working with Chris Webster on the USDA-funded Seeds Project. Seeds Project aimed to use alternative silviculture systems in northern hardwoods and look at their effects and the effects of that and of understory treatments on regeneration from seed. She successfully published 3 papers from just the last one just recently from her PhD project. She went from there to here working as a postdoc on the Northern Hardwoods Resilience Project. I should mention that in between, she also worked on the Northern White Cedar Regeneration Project, a joint USDA Michigan DNR project focusing on the difficulties in regenerating cedar. And from there came to work on, has been a key hub on the Northern Hardwoods Resilience Project, which is funded by USDA Forest Service, working with Crystal Kern and myself and several faculty members here in the Department of Forestry. So without further ado, Claudia.
Thank you. All right, so hi everyone. All right. Northern hardwoods. So northern hardwoods as a forest type span a pretty large area, like in the northeastern US and southeastern Canada. You can see over here, and they do have a long-standing industry, very important for commercial wood products, but also for non-timber goods or things like maple syrup. They have an importance for recreation, hunting, tourism, as a wildlife habitat. They're important for biodiversity and also carry some cultural importance. However, over the last decades, it has become more and more clear that one really big problem northern hardwoods are facing is poor and unpredictable tree regeneration. So there are some stressors that northern hardwoods are facing. Since last weekend, we should all know that suddenly exploding is apparently one issue. But jokes aside, climate change and the expected changes in severity patterns of weather are a stressor for northern hardwood forests. And that kind of goes hand in hand also with the invasive plants, pathogens, and the spread of pests. Another issue are some past logging practices. So a large area of the northern hardwood forest has been exploited in the past. So there have been many areas that have been clear cut with white settlement. And also it has become clear in recent studies that there might be some mismatch between the management that is currently applied to northern hardwood forests and the desired outcomes of like a diverse and sustainable settling community. So the main management or silviculture systems that are applied to northern hardwood forests are selection systems. So some of you are probably familiar with single tree selection, where individual trees are harvested out of the stand, or small group selection. So these are all systems that create only little canopy disturbance. And last but not least, ungulate browse, especially white-tailed deer, is also an issue for the regeneration in northern hardwood forests. So And that brings up some questions. So across the northern hardwood range, what are actually the defining characteristics of this resource? And what is the current state of these forest values? So what species are dominant? How are they distributed? How do they regenerate? Are there any patterns in that regeneration? And then also across the whole range, what are the management practices that are being applied? As I said, mostly selection systems, but there is some variation, especially in things like site preparation that is applied along with the harvest. And so some of the questions we are addressing with the Northern Hardwoods Resilience Project are, where do the current management practices match the expected outcome or the desired outcome? And where do we think that they will continue to be successful in the future? And what are maybe some areas that where changing up the management a little bit and incorporating alternative approaches would provide a great benefit to the regeneration of northern hardwood forests? So as Mike has mentioned, this is and you've seen like the northern hardwood range is pretty big. So it's a big project with a lot of partners that are involved in that. From the U.S. Forest Service, the PIs on the project are Crystal Kern, Laura Knefik, and John Willis. Here at Michigan State, Mike is working on that. Aiden, who is sitting here in the front row, has worked with me a lot in the last year. Parker Hopkins, too, is sitting next to Aiden. Then also Gary Roloff, Andrew Finley, Raju is working on that too, and Emily Silver. And our partner in Canada from the Quebec Ministry of Natural Resources and Forests is Steve Vidar. The funding for this project is coming through the Forest Service, more specifically the Bipartisan Infrastructure Law. And already said, like, our objectives are to quantify the state of the resource and the management. And the expected outcome of this project is to help with a more informed decision-making to promote more resilient northern hardwood forest into the future. And I'm gonna talk about, like, objective 1 here today, our state of the resource. So to assess the state of our resource, there were 2 things that we needed to look into first. A, the range, so northern hardwoods. What exactly does northern mean? And you've seen this map like a few times here now. But if you pay close attention, you see that this map has been adapted from like 2 much older maps. So there is not really a really recent or current map available that shows us the range or extent of northern hardwood forest. So it was one issue we had to address. And then also, what does what does hardwood forest even mean, northern hardwood forest? There's a lot of consensus what species are typically part of the northern hardwood forest, but there's like no hard definition that we could apply to northern hardwood forests. If you work with FIA data, you know that the FIA does categorize their forests. So the FIA uses the term maple beech birch forests, which are pretty close to the northern hardwoods we are interested in. But that data is only available for FIA plots, basically, and also only for the US. And as our project spans all the way into Canada, we also needed to find a definition that works for the data we will have available. So let's start with the forest type. We did use the FIA classification of maple beech birch forest as kind of like a starting point. We had the hope initially that we maybe would be able to replicate the algorithm the FIA is using to determine a forest type, but that was like a little bit too complicated, to be honest, and there are a lot of steps involved. And another issue, the FIA uses a lot of different variables to determine the forest type. So for example, also sapling counts and seedling counts, and that would be data that we wouldn't have available across our data sets. So we adjusted the algorithm to find something that works for us. And the main species that we have in this forest type are red maple, sugar maple, yellow birch, American beech, white ash, black cherry, and American basswood. So those are our main players. And when we wanted to select plots for our analysis, the algorithm we use basically excludes all the plots that are either dominated by conifers, so not hardwoods, or that are hardwoods that are dominated by oak and hickory. We also made it a rule that either sugar maple or red maple in the overstory, so all trees that are larger than 5 inches in diameter are present in the plots. We made it a rule that most of the larger tree basal area in the plots have to come from either these main players or from some associated species like white birch, serviceberry, ironwood, things like that. And lastly, we did exclude plots with a very low basal area because that indicates that there has been like a recent disturbance, like either a harvest or a natural disturbance. All right, so we have our forest type defined. To define the range, we used the so-called CEC ecoregions. These ecoregions are based on similarities in soil types, in weather patterns, and in flora and fauna in certain regions. And to define our range, we selected all CEC ecoregions where northern hardwood forest can be present. Although, disclaimer, not for all the ecoregions, it is the main forest type. So especially, or like one example, when we look over here into northern Minnesota, we have a lot of wetlands there. So we would only find northern hardwoods there on more drier soils, obviously not in the wetlands. But if we have good soil, we can find northern hardwood forest there. All right. Then was time to get some data together. So as I mentioned, there's the FIA data, which we used for this study. And it is by far the biggest data set we have included in the study. We also have on the Canadian side some forest inventories, federal forest inventories, although that was not available for all provinces, so it was not available for Ontario. So for Ontario, luckily we found 2 research data sets, but hence our sampling effort here is much smaller than compared to the other states and provinces. There were also like some long-term research projects that provided us with data that we could include in our data set, and especially on the US side, also some state forest inventories we were allowed to use. That came up to almost 50,000 plots total. Those are, of course, not all northern hardwood plots. So those are just the forest inventories for that region. So we had to select for our northern hardwood plots. So we ran all the plots through a filter to make sure that the overstory composition would align with the forest type we were looking for. And we also made it a rule because we wanted to look into the current state of the northern hardwood forest right now, that the last inventory that had been taken in a plot must have been 2014 or newer. So we have now just over 8,000 northern hardwood plots in our total data set. All right, and when we do just some like very basic statistics or analysis and look at the average basal area distribution of all pole and sawlog sized trees, so everything again that is larger than 5 inches in diameter, we see that the average basal area in all those plots is just about like a little bit more than 100 square feet per acre, or if you want to use the metric system over here, like roughly 22, 23 square meters per hectare. Large sawlog trees make up the most of that basal area. And if we look at the species composition, we see that sugar and red maple together account for roughly 50% of that basal area on average in our plots. If we look at tree density, so that is stems per hectare, we see that kind of like the species composition for the poles and sawlogs, pretty much the same as we just saw with the basal area. So about 50% maples, and then beech and also yellow birch each account for about 10% of the stems per hectare on average in our northern hardwood plots. When we look at the sapling layer, however, so our regeneration, those are all the stems that are between 1 to 4 inches in diameter. We see that that composition or species assemblage is quite different. Maples only account for like a little bit more than a quarter of all the regeneration on average in the stems. And also beech accounts for like almost a quarter of saplings on average in those stems. All right. So now we know how like all those 8,200 plots like on average look like. But we were interested to see if there are spatial patterns, like spatial variation. Do we have areas where we see more of the, like some of the maples or other species we consider desired northern hardwood regeneration, like yellow birch or black cherry. And to do that, we use the so-called, so this is the broadleaf forest cover from the European Space Agency. And that tells us, they derive that from satellite information, that tells us where we have broadleaf forests. Because of course, not everything in our range is like just covered with broadleaf forest, like wall to wall. There are other forest types in there. So the black areas that you can see here in the back are the broadleaf cover. And the green ones are actually two. The green ones is an additional layer I put on top. And this is the area where we expect that our northern hardwood forests are the most dominant forest type. So as I mentioned earlier, this is an area where in the broadleaf forest, or like among the forest types, northern hardwoods can appear, but we do not expect them to be the main forest type or the predominant forest type. So we wanted to only look into the core or like the predominant range of northern hardwood forests. All right, so this map now shows you again like the area where we have within our range broadleaf forest cover in the main northern hardwood forests, or where the northern hardwood forests are mostly dominant. And the different colors you see are coded by the average total basal area of poles and sawlogs. So those are all tree species together, and like all the larger trees. And that gives us some information how dense kind of this forests are there. And I've highlighted two. So this is all the total basal area metric, so square meters per hectare. But I wanted to point out two of those categories. This is 83 to 96 square feet per acre basal area. And if you ever work with the Arbogast guide, you know that this is roughly the recommended stocking for pole and sawlog trees together. Already like pushing it a little bit to the top end. And the Arbogast guide is only for selection systems, right? So mostly single tree or small group selection. So if we have like those green forests, they're kind of like, if we apply a single tree selection, we hopefully can create conditions to get good northern hardwood regeneration. Everything in yellow, orange, and red is well above that. So forests with a really dense overstory, meaning forests that have very little light available for the regeneration layer. And if you look at the map, you see that actually there is quite a lot of areas that have those very high basal area. So those are all averages. So those are kind of small neighborhoods of plots taken together and then averaged and extrapolated. But we have like a little bit of a pattern here that more towards the west, we have stands that are kind of like in the good stocking or like a little bit below. And over here, we have a tendency to see more of those really dense forests. So this map shows you the average sapling density, trees per hectare, of what we consider our desired northern hardwood species. So species that have more of an economic value. And those are all, again, trees per hectare. If we would look at the Arbogast guide, which is in trees per acre, we would see that he recommends about 550 trees in this size class as well stocked. And that would be starting kind of here. So in the almost like 1,000 trees per hectare range. If we look at stocking recommendations for things like shelter woods, so harvest regimes where we open up the canopy a little bit more, those recommendations are about 400 trees per acre, and that translates to about 850 trees per hectare. So these green categories here are already kind of the low range of what we consider well-stocked sapling layers. And as you can see, there's not really a lot of areas where we find on average like suitable stocking of desired saplings. Like we see a little bit more here towards the west, like a tendency, and we also have some hotspots basically for desired regeneration over here, but especially towards the south, we have a lot of areas that are very much understocked with desired tree species. So sugar maple, kind of like I like our main among all the main players, like our most abundant species. It accounts for roughly 1/3 of the basal area in the sawlog size classes and pole size classes. And if we look at, so I didn't categorize that here because there are no really like stocking expectations just for one species. But again, you see like here, like towards the higher range, that is about 700 saplings of sugar maple per hectare, which translates to like roughly 300 little under 300 saplings per acre. And we do see that we have better, more dense, more abundant sugar maple regeneration towards the west of our range, and then also some hotspots towards the north, especially here in the south. Sugar maple regeneration is very low down here, and also in areas where we have some higher elevation, like here in upstate New York, for example. And another species we're going to look at here as an example is beech. And beech is, for us, like kind of from the economic point of view, on the side of the undesired northern hardwood regeneration. It has a lot of value for wildlife, but as a wood product, it is not as desired. So, and it is a very, very strong competitor for sugar maple. And we can see, if we look at the range again, two things. A, beech generation is doing better than sugar maple. Where we have hotspots, we almost have twice as much beech saplings as we had like at maximum sugar maple saplings. And we kind of see that we have hotspots for beech regeneration here in the south, and here, especially like on the higher elevations, where we had cold spots for sugar maple regeneration. And just if you're wondering, this map is also clipped to the natural range of beech in addition. So over here to the east, we just don't have beech naturally occurring usually. All right. So I actually have a map here of both of them together. So again, some of the areas where we do see the low sugar maple regeneration, we have very good beech regeneration. So there is like a spatial correlation between the two of them. All right, so another thing we haven't really talked about yet is, or like a little bit in the beginning, but the actual composition of the sapling layer, of the regeneration layer. And as I mentioned in the beginning, we applied our northern hardwood forest algorithm to the pole size and sawlog trees to select our plots for this analysis. But we then also, at a later point, decided to basically apply the same algorithm to our sapling layer to see if the trees we have regenerating in the sapling layer under northern hardwood forest are the same composition as we see in the overstory. And we actually found that in all the 8,200 plots that have the northern hardwood overstory, there were kind of like 3 different groups in the sapling layer. So we have the plots that are northern hardwood stories in the poles and sawlogs, and also in the sapling layer. So it's kind of what we would hope to see, that the forests are regenerating, the northern hardwood forests are regenerating well with northern hardwood species. But those accounted only for about 3,500 of our 8,200 plots. Almost, well, over 4,000 plots actually were northern hardwood forests, where the composition of the sapling layer was not northern hardwood species. So those were, for example, plots that had a lot of beech regeneration and no maples, or completely different species assemblages altogether. And also we had over 500 plots where no regeneration at all was observed, like within the forest inventory plots. And while we were running this analysis, we actually made a really interesting kind of like discovery. And this was northern hardwood regeneration that occurred in plots that had a different overstory composition. So those were not northern hardwood forest types that still supported northern hardwood regeneration. And that added like 1,700 more plots to our data set. So, oops. Then wanted to kind of like look in like how those are spatially distributed. And you see up here in the left corner, those are our northern hardwood plots. So where the overstory composition, or where the sapling regeneration, the sapling layer matches our source and Pollock composition. There are some areas where the plots are a little bit more clustered, but overall, they're pretty dispersed over our study range. When we look at the plots that had northern hardwood overstory, but a different type of regeneration, so northern hardwood plots or northern hardwood stands that do not support northern hardwood regeneration, we see like a little bit of a clustering here, where we also like saw poor sugar maple regeneration and abundant beech regeneration. Plots where no regeneration was observed are also clustered here towards the south. And then lastly, the plots that had a different forest type, but support northern hardwood regeneration. There are like some pockets, but there are actually dispersed pretty much through our range. So of course, then the next question was, what forest types are those? Like what forest types does northern hardwood regeneration occur? And we kind of like put that into 4 different groups. And we had to use a data subsample for this analysis because we utilized the FIA forest types. So all the FIA plots that we have come with a forest type that the FIA assigned to them. So we could, unfortunately, we had to restrict this analysis to the US because we only have that information for the federal inventory plots in the US. And the first group is actually the FIA maple beech birch groups. So these are all forests that are pretty similar to our northern hardwoods, but did not pass our filter because maybe there was no sugar maple in the overstory. The FIA does also allow for a larger conifer component than we did allow for. So, and you can see that other conifers and hemlock are a big part of the basal area and the sawlog and pole size classes of these plots. So basically, the FIA categorizes these plots as northern or as maple beech birch because they have northern hardwood regeneration. We consider them as not northern hardwood forest, but like in the overstory. The second group are a little bit more boreal and or earlier successional forest types. So we have aspen and birch stands and spruce stands that are concentrated here towards the west of our range. So where we have a larger wetland component coming into our soils too. And then also here on some of the higher elevations. Oak and hickory hardwoods are another forest type. So those are plots that we excluded because in the overstory they have a large oak component, and they are like mostly towards the south here and the southwest. And lastly, various pine stands, mostly white pine stands. And those are actually like kind of like the successional type that is across the whole range, the type that usually comes before the succession of a forest type continues into northern hardwood stands. All right, so that brings us a little bit to the question, what's next? So we now know some of the spatial patterns of overstory densities where we have good and not so good sapling abundance, where we have hotspots for our desired regeneration, where we have cold spots. What we not really know yet is the drivers behind those patterns. And as I mentioned in the beginning, one really big driver is browse pressure. Across the whole range, we have white-tailed deer. In some parts of our range, we also have moose, elk, in Canada, also some caribou. What we don't have is a good browse estimate that covers our whole range. There are a lot of deer studies, for example, but they're usually regional or maybe like putting like some states together, like studies for New England. But it is really hard to assess browse pressure over like such a large range. We did have like a preliminary test that we ran with a data set from Mike's and Evan's Big Northern Hardwood study, because while they were collecting information on sapling density and species, they also collected very good browse information. So how much browse damage was observed on different sapling species. And we found that, little surprising, the more twigs we have that are browse, the lower the maple sapling density is relatively and absolute. So if we have a lot of deer, they browse a lot, sugar maple is one of their preferred browse species, we get less regeneration of that. Unfortunately, having like such good browse data is really, really rare. So there's no way to like get that for our whole range. So we have to use some other indicators that help us estimate this browse pressure. And one is, of course, how many deer are harvested. We ran the study just for Michigan, and if you're a hunter, you know that up until last hunting season, you could only shut bucks up in the UP, so we had to use the number of male deer that were harvested across all of Michigan, because otherwise, like, it got really wonky with total harvested numbers, because people can take those down here. And other factors that we found that are also correlated to how many twigs get browsed, how many deer we have, are actually some other like environmental land cover factors. So we also took that data from the ESA land cover maps, urbanization, so how much urban area do we have affects deer browse. If we have less urbanization, we have more deer. Then there is a vegetation type that is called open canopy. So basically the transition between forests and open areas like fields or pastures. If we have, like, that was a unimodal relationship to a certain point, open canopy is positively associated with deer browse, and after that, after a certain tipping point, is negatively associated. And then lastly, if we have a lot of snow, so if we have a high snow depth, we also get less deer browse. And our plan is now for a whole study range here to use this data, this placeholders basically, to estimate the browse pressure for our regeneration. And we're still in the process of collecting that data. Kat Jones is helping me with that. She has been reading through a lot of annual harvest reports to figure out how we can like best use the deer harvest data, because as you can imagine, there's a lot of variation in hunting policies across this whole range, which makes it really difficulty to find like one number that we can reliably use for the whole range. All right. Oh, and before I forget, don't have a slide about that, but another aspect that Parker is actually looking into with Emily is assessing the management. So to get information how like the forests across our whole range are managed, they will be conducting interviews with forest managers to see what their management prescriptions are, if the outcome they are observing aligns with what they were hoping to get out of the management. And then we're also planning to do some ground truthing to see if there might be a mismatch between what is in the prescription and what is actually applied in the end. So, and hopefully like getting all this information, the spatial patterns of regeneration, the drivers of regeneration, the variation in management will hopefully allow us to model not only spatial differences, but spatial temporal differences in regeneration and in forest values. So this is also just a map from a test run that Aiden is actually working on with Andrew Finley to assess the change in some, in this case, it was maple sapling density, so sugar and red maple taken together over like 15 years. And you can see here darker areas are areas where over that time span, sugar or maple sapling density increased, lighter areas were decreased. And taking all this information together, we can hopefully make forecasts into the future, how different management scenarios will affect those spatial temporal patterns of regeneration. And we still have a few minutes. Really quick, because we want to like one big aspect for this project is to help decision making in management, but also to support management of northern hardwood forests. And we were working with this like really giant data set, which kind of made us aware that there is not good software out there to manage those big forest inventory data sets. Some of you have maybe tried to work with the FIA data and the eValidator, which is basically like you can probably take a class on that and still don't get the table that you actually wanted to see in the end. So our idea was to create a software tool that helps forest managers to analyze and visualize their forest data easily and as an open source, to help them generate summaries and figures that they can export easily. And then the plan was to have a Shiny app that is really easy to use for a wide audience, so for not as computery people, and an ARC package for technical users. And Aiden has been working over the last year really hard to turn this idea into our application for Maple, the forest management and analysis platform that allows users to upload their own data. It is really flexible, so it works with plot data, or if data is in polygons, it can be uploaded in a variety of file formats. If people want to use public data like the FIA data, they can upload it in there, and the tool automatically formats it to do its calculation. It also works on the fly, so you can like see what you're interested in like immediately. I'm just going to show you really quick so you get an idea how that looks like. So this is kind of the user surface, and this has all our like our whole data sets basically in here, our 50,000 plots. And on the left, there is like a lot of, I think we're only showing here. Yeah, so you can change the how you want to visualize these points, how you want to group the points, but you can also use the filter function to select plots that have a certain basal area threshold, that have certain size classes, that have certain species in certain size classes. And then you can get on the fly like a really nice summary. So this is just basically from all the plots we just saw by state in the US and by species, like the trees per acre. But there's a lot more you can do with that, and like all that information can like just be downloaded by the user. So if they want to give a presentation to their supervisor, it is there. And actually, if you want to like see more what you can do with this app and also hear about all the technical background stuff that I cannot tell you, I would highly encourage you to check out Aiden's presentation in about 2 weeks in frame of the GSO symposium in this room. All right, so to summarize takeaways really quickly, range-wide, the desired northern hardwood regeneration is understocked. Less than 50% of northern hardwood plots in our study actually support northern hardwood regeneration, and there's a lot of spatial variation between good or hot spots and cold spots for desired northern hardwood regeneration. There is some spatial correlation between sugar maple density and beech density in the regeneration layer. And there might be some spatial correlation between these areas with like really, really high pole and sawlog density. So where we just have like really dense dark forests that don't give a lot of light for the regeneration. But we're like still in the process of analyzing that. And the good news is though that other forest types can also support northern hardwood regeneration, and that provides us basically with a reserve of those species across the whole range, even though within the northern hardwood plots or stands, the regeneration is looking not that good at the moment. All right, so thank you very much.
So how do you think beech leaf disease, beech bark disease will affect your stand in regards to what the understory composition might be going into the future?
That is something we will absolutely look into, hopefully, because like right now we're not even taking any disease or pest into account. It can be devastating, right? In areas where we basically only have beech or have like a very, very big beech dominance, and especially if we don't have a overstory seed source from other species, that could be devastating. In areas where we do have seed sources of other like more desired species, it might also be not the worst thing to happen, but from an economic perspective, I actually do like beech. So all right. Any more questions right now?
No question from the Zoom folks. So let's give big hand to Claudia.